We're now moving on to our next video, Unit 3F. This will be our last video before we move on to OELP, most likely, and you will have to watch a couple of videos over OELP. And we're going to still be doing subtracting integers, but now we're going to be looking at adding and subtracting, and just looking at them in a couple different ways. So what we need to know in this video is just be able to add and subtract, or add negative and positive integers. And then this one, we're going to know how to subtract negative integers. All right, so what if our problem is 5 minus negative 2? What do we do? All right, so in this example, or this video, we just have a bunch of examples we're going to go through, and then just one thing I'm going to explain before we do these negatives, minus and negatives. All right, so there are like 10 examples that we're going to cover. All right, so the first example, 5 minus 3. Obviously, I expect that you guys can do this. I'm just showing you the number line just to talk about what we're doing with the number line here. We're starting at 5. We could use the number line 1, 2, 3. That means we end up at 2, so we know that 5 minus 3 is equal to 2. By no means will I expect you to use the number line for this, but I'm just using this example to segue into our next problem, which appears a little bit different, but it's actually the same thing. All right, so for this problem, it says negative 3 plus 5. Well, what is negative 3 plus 5? So we can start at negative 3 and we can count 1, 2, 3, 4, 5 and end up at 2. And negative 3 plus 5 is equal to 2. So we just said 5 minus 3 is equal to 2 and negative 3 plus 5 is equal to 2. Well, does that make sense? And yes, it should, because you guys have learned something before called the commutative property. And that tells us that A plus B is equal to B plus A. So when we see this negative sign written out first of negative 3 plus 5, we could rewrite this as 5 minus 3 and present it in a way that's a little bit easier for us. So if I give you negative 8 plus 14, this might look difficult to begin with, but we can rewrite it as 14 minus 8, and you should be able to solve that that is 6 very easily. All right, so I was just showing you here with the number line that these numbers or these questions I gave, these expressions are actually the same thing. So sometimes it's just beneficial for us to rewrite them in a way that makes it easier for us to solve. And just make sure if you are going to rewrite them, our sign stayed with it. So see how the 3 had the negative in front of it? It still has a negative in front of it. The 5 was positive, it's still positive here. All right, once again, just 4 plus 3. We can use our number line, which you obviously shouldn't need for this, but it's equal to 7. We can use our number line of negative 4 where we're adding 3, so that means we're moving to the right. So 1, 2, 3, and and 4 plus 3 is equal to 7. All right, I'm just showing you using the number line here because we're about to do another problem which may look a little bit different and a little bit harder, but I'm going to show you how we can do it the same way. All right, so 4 plus 3, you should know that that is equal to 7. All right, what about negative 4 minus 3? Well, we need to plot our first point at negative 4. Now we're subtracting 3, so that means we're moving to the left. So then we will move 1, 2, 3, and there is our new point at negative 7. So we just did a problem that 4 plus 3 is equal to 7, and we just did another problem that negative 4 minus 3 is equal to negative 7. Don't these look awfully similar? 4 plus 3 is 7, and negative 4 minus 3 is 7. If we have two of the exact same signs, so both of these are positive, we can add them, and our answer is positive. If we have two of the same signs and are both negative, we can still add them. 4 plus 3 we know is 7, and since both of these signs were negative and we're adding them or subtracting them, then this is just negative 7. We're not multiplying here. All right, so just remember, here we are not multiplying, because if we start with a negative number and we're subtracting from that, we're obviously going to stay as a negative number because we're moving even further to the left. But in our mind, we can go ahead and add them. So if I give you negative 8 minus 13, I see that these are both negative. Well, 8 plus 13 I know is equal to 21. So my answer will be negative 21, because as I start at negative 8 and I move 13 spots, I'm going to still remain a negative. Right, so negative 7 minus 6, well, we can start at this negative 7. We are subtracting 6, so we're moving to the left 6 units. 1, 2, 3, 4, 5, 6. So I know that I'm finishing at negative 13, so I know that this is equal to negative 13. Well, we could have done 7 plus 6, which is 13. And since we know we're starting at minus 7 and we're removing 6 more, we know we're going to finish at a negative. So we could have just done this and said, well, negative 7 minus 6 is equal to negative 13. All right, you see here, we are subtracting. It's important that you understand that we're subtracting this and we're not multiplying. Because if we were multiplying, we'll learn, maybe not this year, but next year, that it changes our values a little bit more. Right? So in this case, when we're subtracting, we know that we're starting with a negative number and we're just moving even further left, which means we're getting even further in our negative direction. So we know our answer is still going to remain negative. But to get to that, rather than writing this number line all the time, we could just go ahead and add them together. All right, let's move on to the next example. All right, so before we move into the last type of examples that we're going to do together, I want to talk about this word takeaway. If I ask you, what operation do you think takeaway means? Think about that for a second. What operation do you think? And now, if you're not sure, what if I say 5 take away 5? What do you think this means if I ask you to rewrite this as a mathematical expression? Well, you already have the numbers 5. Takeaway means subtract. And 5 minus 5, well, if we're taking away exactly what we have, 5 take away 5, well, what should we end up with? We should end up with 0. If we're taking away everything that we have, we should be at 0. Right? And it makes sense when it's two positive numbers like this. So we have 5, 1, 2, 3, 4, 5. And here, if we're at 5 and we're taking away 5, well, we're moving to the left here 5 units. All right, now, what if I tell you, though, negative 5 take away negative 5? Based on what I was just saying here, we know that if we're taking away the exact same amount that we have, we need to end up at 0. This is going to be equal to 0. So now this becomes minus 5. Take away we know is subtract. And we're taking away another minus 5. So here we have two negatives, a double negative. Well, if we know that we need to end up at 0 and we're at negative 5, well, what direction do we have to move in order to get to 0? We need to actually move to the right. And we will move 1, 2, 3, 4, 5 units to the right. Well, when we move to the right, we are increasing, or we know that we are adding. It's being plus. So from thinking about this, we can think about it as negative 5 plus 5. So when we have a double negative like this, that's actually going to turn to a plus. Right? I'm going to try to explain this to you in a few different ways. If I said to you, you cannot not drink in class. Hold on. If I give you this statement, you cannot not drink in class, what do you think I'm ultimately telling you that you're allowed to do? Because by putting these nots next to each other twice, they actually are going to negate each other and cancel each other out. And this statement is actually telling you that you can drink in class. So we can think about that in terms of a minus sign as well. If I give you negative 5, well, it doesn't matter if it's the same number. I'm just going to give you 5 minus negative 3. This is like saying two knots together, and they're going to cancel each other out. And this actually turns to 5 plus 3. All right, so you can think about these negatives as a double negation, like with our sentences. If we said you cannot not drink in class, it actually turns to a plus. Just like this actually turns to saying you can drink in class. Because I'm saying, first I'm telling you not to drink in class, then I'm telling you not to do that, which means you can. All right, so another way that we can think about this, way that we can think about this is when we were talking about opposites the other day. And we referred to these formulas I told you are going to be important. So remember, A represents any number. No number is 4. Well, when we're taking the opposite of that number, we could represent it by saying minus 4, the opposite of 4. And when we're taking the opposite of an opposite, we know it brought us back to our original number, which in this example is 4, because we know that those two opposites actually cancel each other out. right? So we talk about this and kind of referring of what these symbols and what the opposite of an opposite actually represents, right? So this here was also teaching us that if I were to do 3 minus -4, that we're doing the opposite of an opposite. And then that is going to actually become 3 plus 4, which is then going to be equal to 7. All right? It's important that you understand that when we're minusing a negative, it turns to an addition. Right? Now we're going to do a problem using a number line, and I'll show you how the number line can also tell us what we are doing. All right. The question is 8 minus -12. 8 minus -12. So if I were to put this minus, or this 8 here, all right, if I were just to tell you it's 8 minus 12, well, this minus sign tells me I'm moving in the left direction. So when I see this minus sign, it's making me think, well, I'm going to have to move left. But then when I look in here again, it's actually telling me I'm minusing in the opposite direction. So instead of me moving left, because I see it's 2 negatives, it's actually telling me I'm going in the opposite direction. So I actually have to end up moving right. And it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I know that this is going to be equal to 20 then. Or the way I can rewrite this, let me just actually erase this, is what I can do then is this 8 minus a -12 actually turns to 8 plus 12, which is 20. All right, because the 2 negatives, just like the 2 knots, they negate each other and becomes a positive. Or we can think about it as it's the opposite of the opposite, and then that means that our original number that we have here is that A, which would then in this case be that 12. Or this minus sign is telling me that I need to subtract and move left, but then this minus sign is actually telling me, well, wait a minute, when you're going to start moving, I also need to now move in the opposite direction because I have 2 of them. And it's actually telling me I need to move right. All right, but what we could just do is this 8 minus -12 becomes 8 plus 12, or 20. All right, and you're going to learn about this a lot more next year. This is just an introduction to it. So we can do a couple problems this year with it. All right, so for this one, actually, let me change the number line real quick. All right, so for this one, we have 13 minus -2. So what I could do is with this 13 minus -2, well, I know the 2 negatives is actually going to turn to plus. So 13 plus 2, which is 15. Or I can think about it as, all right, I'm plotting my 13. This negative sign is telling me I'm moving left, but I'm moving left in the negative direction too. And that actually is telling me I need to move right too. So 1, 2, and here will be my point, 13 or 15, and that will be my final answer. All right, that is it for this video. I know this one was a little bit longer, but we just needed to go over a few things.